Okay, welcome back everyone, and welcome to our integration recap for definite integrals. Now, lucky for us, definite integrals are super easy to do once you have already done the indefinite integral, so we're going to be using the exact same function and just taking a look at what happens when we're not looking for the indefinite integral, when we pick an a and a b and look for the definite integral. Because the definite integral that's all it is you're picking an a and a b. In this case, I sort of have these two on my little plot over here. And we're going to solve for the area under the curve between the x-axis and the function between a and b. So unlike the indefinite integral, which gave us a function, we're now going to use that function to find the actual area under the curve. So what that looks like is we want to find the integral of f of x dx, but we want to do it from a to b. So our notation looks very similar, the only difference being those two ends, a and b, telling me where I want to fulfill my integral from. So in this case, let's go ahead and pick an a and a b. For this function, let's go from a equals -1 to b equals 2. So sort of roughly where I've drawn them out here. For this function and that a and b in particular then, what I'm looking for is the integral from -1 to 2 of negative x cubed plus 2x squared plus 2 dx. So this is my definite integral notation. This tells me that I want to find the integral from -1 to 2 of negative x cubed plus 2x squared plus 2 dx. Now, as I mentioned before, solving this is actually pretty much identical to taking the indefinite integral, because the first thing we're going to do is find the indefinite integral of this function right here, which we already did in the last video. So we can just, boop, take that right there. And the integral, oh, interesting, rogue 3 here. Let's move that out of the way. So now I've actually already found the indefinite integral of that function. Amazing. So I'm already well on my way to solving my definite integral. The difference here is that when I have the definite integral, I want to include a little bar on the edge here. So I'm going to go ahead and get rid of some of the fluff over here, because this is going to be equal to this, and I have my bar from a, -1, to b, 2. So just like I need to include my ends in my actual integration symbology, I need to make sure I include it in my solution as well, because this is reminding me that I'm not done yet. I have not finished everything I need to do. I still have to use this function to find the area between -1 and 2. So let's look in general, because we always like to start generally, and then we can go more specific for our given problem. So in general, when I have some f of x from a to b, the way I solve this is by doing f of b minus f of a. So all I have to do is plug in my endpoints to my function where I need to, and I am rocking. So let's take a look at what that looks like here. So f of b we'll do in green, and remember b is 2. F of a we'll go ahead and do in pink, and remember a is -1. So for my specific function, what this is going to look like is we'll start with f of b. So -1/4 b, which is 2, to the 4th, so I've just plugged in b for my first x there, plus 2/3, b is 2 cubed, plus 2b plus c. So all I am doing is I'm saying I've got this term here, this term here, this term here, this term here, and I've plugged in b wherever I have my x's. So that is my f of b. And I'm subtracting f of a. So let's go ahead and do the same thing for my a's. So -1/4 times -1 to the 4th, plus 2/3 -1 cubed, plus 2 times -1 plus c. So same thing, I'm just plugging in my -1 for everywhere I see an x in my function and subtracting it here. Now at this point, we can see that we're going to have some pretty nice stuff going on, because, let's clean this up a little bit. If we look at our, if we look at our function here, you can see that right off the bat some nice stuff is going to happen, because if we're subtracting, if we have this minus sign for all of this stuff, this is going to become a minus c. So if I have a plus c and a minus c, these guys are just going to cancel out immediately, so I don't even have to worry about my c's. So those are out of the picture, which means I just have a bunch of numbers left over. So let's go ahead and do a little bit of solving for what those numbers are. So first things first, -1/4 times 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16, plus 2/3. 2 cubed is 8, plus 4. My c goes away. So that's sort of my first term. And then I'm subtracting all the stuff in my other brackets here. So I am subtracting -1/4. -1 to the 4th is going to be just 1. 2/3, -1 to the 3rd is -1. 2 times -1 is -2, and my plus c goes away. You have to be careful when we're doing this, because you have to remember our negative sign is going to be distributed into all of these terms. And I'm going to go ahead and do some combining of constants. So -1/4 times 16, -16/4 is just going to be -4. 16/3, we'll leave that way for now, plus 4. Now we have to be careful of our minus signs. So minus -1/4 is going to be plus 1/4. Minus -2/3 is plus 2/3. And minus -2 is going to be plus 2. So when I add these all together, I get a grand total of 8.25, and a quick double checking of an integration calculator confirms that the integral of -x cubed plus 2x squared plus 2 from -1 to 2 is in fact 8.25. And that's it. That's all I do. I find my indefinite integral, plug in my b's, subtract what happens when I plug in my a's, I get a number, and that's the area under my curve. All right, so this is all of your required listening for today. What I'm going to do now is come up with one more example video that'll tie in both the indefinite and definite integrals, because remember, to do the definite you have to do the indefinite, and I will post those examples to YouTube. But if you feel good about this, I'm going to go ahead and give the practice problems a try. You're welcome to do so.